Okay, in Objective 5, we are looking at defining absolute values as piecewise defined functions. We've obviously worked with absolute values for years. We should all know at this point that the absolute value of 3 is 3, that those absolute value bars are therefore superfluous. They don't do anything to my number. But that if I had, for example, the absolute value of -3, well then that -3 would become a +3. Okay? And then over the years, we've obviously built on this idea of an absolute value, starting to look at functions with absolute values in it and that sort of thing. And last week, we reviewed how to graph a linear absolute value function. For example, the absolute value of x plus 1 minus 4. We learned to turn that into its descriptive form. Or we reviewed how to do that. Pull out the starting point of -1, -4. Right? And then a slope of 1, up 1 over 1, up 1 over 1, giving us kind of the traditional V shape of the linear absolute value. Okay? But today we are going to be looking at what it means, I should say, what it means to actually be an absolute value function, right? Beyond that kind of fact of sorts that the linear absolute value makes a V shape. And so I wanted to demonstrate what this function is saying by looking at the function y equals 2x plus 1, right? If I asked you to graph that function y equals 2x plus 1, you might turn it into descriptive form by subtracting the 1 over. Maybe you graph it here in slope-intercept form, but you would get a function that looked like this, right? Y equals 2x plus 1. Okay? With an absolute value, okay, when I take that same function and put absolute values around the x, what happens? What changes about my graph? And I don't mean that like now it's a V instead of a line. Like literally, how does this graph change to create this one? And so if you need to, maybe pause the video, graph this one really quickly, and compare the two. How does this one change to create this one? Okay? And so here you would turn it into descriptive form, right? You would plot your starting point, and you would have your slope in either direction, right? And so looking at these two functions, take a look here. On the right side of the y-axis, my graph is actually exactly the same. Look at, I have a point at 0, 1, a point at 0, 1, a point at 1, 3, a point at 1, 3. Right? All of those are exactly the same. What has changed is what's on the left side of the graph, right? This piece here on the left side, starting at 0, 1, that went down, now has been reflected up and over and is going up now instead, right? It's like there was a little hinge at this 0, 1 that forced this line upwards into its V shape. Okay? Well, why does that happen? That happens because when we have absolute values, what is happening is there is a positive leg here. I'm going to go ahead and write positive leg. That when I put absolute value bars around whatever my function is, nothing changed, right? In this particular example that we're looking at here, the positive leg is this right side of the y-axis, right? And the absolute value bars didn't change anything about it, right? That would be like my absolute value of 3, where the absolute values didn't do anything. And so removing the absolute values would be just fine, right? It was the same graph anyway, so I don't need them. Same idea here, right? If I removed these absolute values for the positive leg, nothing would change, right? That right side of the y-axis, the graph would be exactly the same. Okay, but then there's also a negative leg to every absolute value. And that negative leg is changing, right? When I put absolute value bars around my function, that negative leg gets reflected upwards, right? Or I should say gets reflected in the opposite direction. So in this case, because the negative leg was going down, it now is going up. For the negative leg, if I just removed those absolute value bars, my graph would change, right? If I removed these absolute value bars, this negative leg would drop down again, right? Because there's nothing forcing it to be positive. That negative leg is like the -3 here that is being forced to be positive. Okay? And so this idea of a positive and negative leg is there for every single absolute value you are looking at. There's one part of an absolute value where having the absolute value bars is changing nothing about it. And then there's another part that the absolute value bars are doing something, right? And so we have to remember that as we are looking at our absolute values. Okay, so what does that mean for us today? Well, we're going to be looking at 3 types of problems. What that means for this first set is that as we are rewriting each expression as an equivalent simplified expression using the definition of the absolute value, specifically making sure, do not use the symbol for the absolute value bar, right? AKA, remove the absolute values. For this first set of examples, what this definition means is we need to figure out, does my number inside the absolute values, my A in this case, are the absolute value bars actually doing anything? Because if the absolute value bars aren't doing anything, if the number is already positive, right, like my +3 over here, if the number is already positive, well, I can remove the absolute value bars and I'll be just fine, right? It's still the same number anyway. But this absolute value of -3, if I'm working with the negative leg, right, we all know that the absolute value of -3 is 3. If I decide, you know what, I'm going to remove those absolute value bars, well, does -3 still equal the 3 that I know it's supposed to? No, right? -3 doesn't equal 3. And so that means if I want to remove those absolute value bars, right, if I want to be able to write just -3 and not have to write the absolute value, what do I need to do to make sure that this still equals 3, right? These 3 things need to be equal, right? Absolute value of -3 equals 3. So if I remove the absolute value bars, I need to make sure that that term still equals 3. And so what do? Well, I multiply it by a negative. Because a negative times a negative is a positive, and so now it equals 3. So yeah, I can remove the absolute value bars if I want. I just have to make sure that my final answer is still going to be positive, right? There's a negative leg that the absolute value bar is changing. And so I know this is a little weird at first, so I have 4 of these so we can walk through them together. And so I would recommend watching maybe 1 or 2 and then pausing the video and trying the next couple on your own. Or maybe watching 1 and then trying 1 on your own and then watching 1, trying 1 on your own, something like that, so that you can get that feel for what we're doing here. Okay? So number 1, I want to remove those absolute value bars. The question is, can I just remove them and not have to worry about it because the number inside was going to be positive anyway? Or do I need to multiply by a negative in order to make sure that the negative number inside of the absolute value becomes positive? Because remember, absolute values are positive. And so if I have a negative leg, I need to multiply that value by a negative to force it to be positive, right? So the question then becomes, well, is 1 minus √2 without absolute value bars, is that still a positive number? And the answer is no, right? This is like √1 minus √2, which is definitely a negative number. And so these are not equal. This is a positive number. That is a negative number. They are not equal. But if I take my negative number and multiply it by a negative, well, now I have a positive number equals a positive number, right? And you can even further prove this if you want by distributing that negative in. Negative times the negative √2 would be positive √2. Negative times the 1 is -1, and that is a positive number, right? You can even double check it if you want. Pick up a calculator, pause the video, pick up a calculator, plug in the absolute value of 1 minus √2, and you will find that it gives you the same value as √2 minus 1, right? We are making sure that these stay equivalent, okay? Okay, let's go ahead and look at another one. I'm going to do number 3 next. Okay, we have the absolute value of 4 minus x squared, knowing that all of our x values are either less than -2 or greater than 2, right? So whatever x value gets plugged in here, we know it's either going to be less than or equal to -2 or greater than or equal to 2. Okay, so I want to remove my absolute value bars, which I can as long as these are in fact equal. Okay, and so think about it for a second. My 4 minus my x squared, absolute value, I know that's positive. Would 4 minus x squared without the absolute value bars still be positive? Okay, well x is, for example, maybe 3, right? There's a lot of values for x you can use. It doesn't matter which one, right? As long as it's less than or equal to -2 or greater than or equal to 2. So say my x is 3. Okay. If I put 3 in here, I get 4 minus 9, which is -5. Absolute value, that's a 5, right? I'll go ahead and put that really small underneath. Absolute value of 4 minus x squared is like 5. What if I take that same 3 and plug it in here? Do I still get 5? Is it still positive? Well, no, right? 4 minus 9 would be -5. These are not equal. And so I need to take this value and multiply it by a negative. Because now, since I'm multiplying that -5 by a negative, now it will be positive, right? This will be x squared minus 4. Plugging that 3 in again, we get 9 minus 4, which is 5. These are all now equivalent. We are forcing it to remain equal. Okay, coming over here. Absolute value of x minus 1. I want to remove my absolute value bars. Okay, I can, as long as it stays equal. X, we know that we don't know exactly what the one number x is, but we know x is greater than or equal to 4. And this number here is a positive number, right? Take a number bigger than or equal to 4, maybe 7. Again, doesn't matter. If I plug that in here, I get absolute value of 7 minus 1, which is 6. Okay? So when I plug that 7 over here, I should still get a positive 6. If I don't, I have to multiply by a negative. I have to change the sign to force the functions to stay equal. Okay, so again, when I took 7 and plugged it in here, I got a 6. When I take 7 and plug it in here, what do I get? 6. Okay, and so I'm good to go. I don't need to multiply by a negative. This function, for all these values that are bigger than 4, this function is positive all the time, and this function will be positive all the time. And so I'm going to leave it alone. Those absolute value bars weren't doing anything to my number anyway, right? As opposed to over here, where it was taking the original -5 and forcing it to be a positive 5, right? Then we had to multiply by a negative in order to make sure everything stays positive. The whole goal of this is make sure everything is positive, right, when you're changing your absolute values. Okay? And then last but not least, we have these. Okay, so we have our absolute value of 2 minus pi. Let's go ahead and focus on that one first. I want to remove the absolute values, which I can as long as it stays positive. Okay, so 2 minus pi, is that still positive? No, pi is like 3.14, and so I need to take that number and multiply it by a negative so that now this negative number becomes positive in the same way that absolute value of 2 minus pi is positive. And again, if you question this, plug it into your calculator. Take your calculator, plug in the absolute value of 2 minus pi and see what you get. Then plug in negative times 2 minus pi, and you'll see if you plug both of these in, they give you the same value, right? You're making sure they stay equal. Okay, and then the last one, I want to remove my absolute value bars here, which I can as long as it stays positive. Is pi minus 2 a positive number? Yes, it is. And so I'm going to leave that one alone. It's already positive, right? Again, if you pick up your calculator and plug in the absolute value of pi minus 2, and plug in just pi minus 2, they'll give you the same value, right? They're already equal. I'm not going to change them. They are equivalent already, right? And so then cleaning this up, we have negative 2 plus pi, distributing that negative, plus pi minus 2, which is 2 pi minus 4. Okay, if there are questions, write them down now about this. Write them down over here. Okay? Second set of problems. So building a little bit more, we're still using that idea of positives and negative legs, right? We're going to now take a function, not just a number like we were doing in 1 through 4, but an entire function. And we are going to rewrite it as a piecewise function that does not contain absolute value symbols, right? And so we have an example here that I want to walk through together before we practice a couple, okay? If I wanted to rewrite this absolute value of x minus 2, there are two things I need to do. Step 1, I need to find the 0 of the absolute value. And so, for example, with this absolute value of x minus 2, it means taking the x minus 2 and setting it equal to 0 to figure out that x equals 2. Why do I need to do that? Because over here, that 0 is going to create the edges of your two intervals. We are going to have one interval that is going to be greater than or equal to 2, and one interval that's going to be less than 2. And for the record, it doesn't actually matter whether you put the equals with the greater than or with the less than. I always put it with the greater than when I'm writing my own function. I don't really have a good reason for it. I just like to do that. If you wanted to put your equals down here, that would be fine. Make sure, though, that for problems like these, that your equals is on one of them. Doesn't matter which one, but make sure your equals is on one of them. I will always be putting it on the greater than. Okay? The second thing that we will then be doing is to figure out negative versus positive legs. And this second step is going to be pretty much exactly what we were doing up above. We're going to find the negative and positive legs because when I remove the absolute value bars, notice I have that x minus 2 in both of these. When I remove the absolute value bars, the positive leg, I'm not going to do anything to it. I'm literally going to write whatever I already started with as my positive leg. When I figure out what my negative leg is, then I'm going to take what I started with, I'm going to be multiplying that value, the absolute value piece, in this case x minus 2, I'm going to be multiplying that by a negative in order to take the negative, multiply it by a negative, and force it to be positive like my original function is. Okay, so the second step is what we were practicing up above. We're just going to do more of it. Okay? Okay, so we're going to do number 5 here together, and then I'm going to recommend you pause the video and try number 6 on your own, right? So I want to rewrite this as a piecewise. Okay, so let's go ahead and do y equals, we're going to do our little squiggly brackets for my two legs. And then you're going to want to leave a kind of chunk of room here, right, because we're going to be writing a function in. And at the back, we are going to write if x and if x, and then you need one to be a greater than, one to be a less than, and one of them needs to have an equals. Again, I always put the equals on my greater than. Doesn't technically matter which one. Make sure it's on one of them. Okay, and so then what is this number right here? Well, that number again comes from finding the 0 of the absolute value. So the 2 here, right, came from because we set x minus 2 equal to 0. So over here we are setting x minus 4 equal to 0. because that's the absolute value, right? The 0 of the absolute value. And so your 0, adding that 4 over, would be 4. Okay, that's step 1. Step 2, figure out the negative versus positive leg. Okay, so up top here, I want to remove my absolute value bars, which I can as long as this stays positive. Okay, so we're going to do exactly what we did up above. Okay, my absolute value of x minus 4 is a positive number. Here my x's are greater than or equal to 4. Okay, so think of a number that would be like greater than 4. We'll go with 6. Okay, if I take 6, this absolute value would be 2, right? The absolute value of 2 is 2. Is this, without the absolute value bars, still 2? Yeah, right? 6 minus 4 is still 2. These absolute value bars didn't do anything to 6 minus 4. Absolute value of 2 is still 2, so removing the absolute value bars doesn't matter. Okay? And so this one we're going to leave alone. Meaning that I'm pretty sure this one's going to be the negative leg. But I always recommend double checking just to be safe. Okay? So I want to remove the absolute value bars, which I can as long as it stays positive. Okay? We have less than 4 for this one. What would be a number less than 4? Like 0, right? If I plug 0 into this absolute value, I get 4, right? Because 0 minus 4 would be negative 4, but the absolute value of negative 4 would be 4. So when I take 0 and I plug it into my original function, I get 4. When I plug 0 in here, do I still get 4? No, right? I get negative 4. These are not equal. And so I need to multiply this by a negative, and so I'm going to put it outside of the absolute value piece. Okay? Because now when I plug in 0, I still get negative 4, but I'm going to be multiplying it by a negative, which is going to give me a positive value. Okay? Okay, number 6. Again, I'm going to recommend you pause the video. We have y equals, curly brackets, leave room for your function. The back, we're going to have an x greater than and an x less than. Again, one more time, it does not matter where you put the equals, just make sure it's there somewhere. Okay? Okay, find the 0 of the absolute value. We'll be taking that x plus 1 and setting it equal to 0, which means x equals negative 1. And step 2, figure out the negative versus positive legs. Okay, so I want to remove the absolute values, which I can do as long as it stays positive. Okay, we have something bigger than negative 1. What's a number bigger than negative 1? Like 0. Okay, originally, this is the absolute value of 0 plus 1, which is the absolute value of 1, which is 1. Right? So when I plug 0 into my original absolute value, I get 1. When I take 0 and I plug it into my removed absolute values, do I still get 1? Yeah. Right? And so I don't want to change that one. That's my positive leg. It was 1 originally for the absolute value of 0 plus 1, and it's still 1 with 0 plus 1. Which means I'm pretty sure this is my negative leg, but let's go ahead and double check it here just to make sure. I want to remove my absolute value bars, which I can as long as it stays positive. What's a number less than negative 1? Negative 3. When I take negative 3 and plug it into this absolute value, I get the absolute value of negative 2, which is 2. Right? When I take negative 3 and plug it into this absolute value, I get 2. So when I remove the absolute value bars and I just have x plus 1, and I take that same negative 3 and plug it in, do I still get 2? Well, no, I get negative 2, right? And so this is the one. I'm going to add a negative out front of that absolute value, making it a positive, so that now, okay, I will end up with my 2. And this one I would say is a little bit weirder to kind of see. And so one other strategy you could always use if you are sitting in a situation where you're like, that was a little weird, I'm not 100% sure I got it. You could always evaluate the function as a whole, right? So let's go back to this one, taking that 0 and plugging it in, right? We get 3 minus absolute value of 0 plus 1, which is 3 minus 1, or 2. When I plug 0 in here, do I still get 2? Well, yeah. Right, when I take this negative 3 and I plug it in, I get 3 minus the absolute value of negative 2, which is 3 minus 2, or 1. When I take the negative 3 and plug it into this guy, I get 3 plus negative 2, which is 1. Right? So you could always evaluate the function as a whole if you want to. I myself, though, typically just look at the absolute value, like I've been demonstrating. Okay, again, if there are questions, write them down now. Last set of problems. Okay, we are going to rewrite these as a piecewise function, and we are going to graph them to give us a little bit of extra practice with graphing. Okay, so graphing piecewise functions was actually done 2 lessons ago. So graphing piecewise functions was part of Objective 3. The piece for today, the new piece for today, is going to be the rewrite here. Okay? The only reason we are separating these two problems from these two as a slightly different problem is because of this fact. These two steps here are going to still be the same. Okay? So I'm going to go ahead and go y equals, leave some space here, if x is greater, x is less. Here's the only difference between this type of problem, 5 and 6, and these two with 7 and 8. There's no equals in 7 and 8. Okay? And I'll explain why as we walk through number 7. Okay? Step 1, find the 0 of the absolute value. Okay? So my x minus 4, I'm going to set it equal to 0, which means x equals 4. Right, so I'm going to put my 4 here. Here's why there's no equals when we have a fraction like these that are going to end up reducing. Equaling 4, if I plug 4 into my function for equals 4, what will my denominator equal when I plug in x equals 4? I'll get a 0 in the denominator, right? I can't have a 0 in the denominator. That is literally the only difference between these two. Here they didn't have a denominator that could equal 0, so I was able to equal my 0. Here we have a denominator that could equal 0, and so we have to be careful. Right? There's not going to be an equal, so it'll just be a greater than and a less than. Okay? Everything else is the same. Okay, step 2, figure out the negative and positive legs. So I want to remove my absolute value, which I can as long as it stays positive. We are greater than 4. What's a number greater than 4? 5. Okay, when I plug in absolute value, or when I plug my 5 into this absolute value of x minus 4, what do I get? Get the absolute value of 5 minus 4, which is the absolute value of 1, or 1. When I remove the absolute values and I just have x minus 4, do I still get 1 when I plug 5 in? Well, yeah. And so I'm not going to change anything. I'm going to leave that function alone. Okay? Down here, I want to remove my absolute value, which I can as long as my function stays positive. Okay? My absolute value function. What's a number less than 4? 0. When I take the 0 and I plug it into the absolute value of x minus 4, what do I get? I get the absolute value of negative 4, which is 4. When I take 0 and plug it into just x minus 4, do I still get 4? No, I get negative 4, right? And so I'm going to multiply a negative to the absolute value function to force it to be positive. Okay? And so we're also going to, like I said, do a little bit of extra practice here with graphing. And so for graphing this one, I myself don't really want to graph it in this form. It's possible you might be able to do so accurately, but I am going to recommend that you simplify. Because if I factor a negative out of the denominator here, I get x minus 4 over negative x minus 4, which those will then be able to simplify. And if I factor, actually, you know what, for this one, let's distribute that negative in, right? Negative times the negative 4 is 4. Negative times the x is negative x. Those are going to simplify as well, leaving me with, up here, negative 1 if x is greater than 4, and 1 if x is less than 4. Okay? So we have a y equals negative 1, which is a horizontal line. So y equals negative 1. Go ahead and grab my pencil here. Y equals negative 1 is this line down here. Okay, what's the only piece that we are keeping, though, for this y equals negative 1? Okay, we're only keeping greater than 4, so I'm going to go ahead and make sure that none of this stuff that is less than 4, it remains. So I'm right here. Okay, and then whole or point. Okay, there's no equals, so that is a whole. Okay, then we have our y equals 1, which is up here. Okay, what's the only part that we're keeping? Okay, less than 4. So erase everything that's not less than 4. Okay, and whole or point. Okay, no equals, so it's a whole. Okay, last one. Go ahead and pause the video, give number 8 a shot, restart it when you're ready. Okay, rewriting as our piecewise. Leave some room. We have an x is greater and x is less than, okay? So step 1, find the 0 of the absolute value. Let's go ahead and take that x plus 2, set it equal to 0. Where's my 0? That'd be a negative 2. Okay. And then, rewriting this, I want to remove my absolute values, which I can, oops, parentheses, as long as it stays positive. Okay, so we are currently greater than negative 2. What would be a number greater than negative 2? Like 0. When I plug 0 into absolute value of x plus 2, what do I get? I get the absolute value of 2, which is 2. When I remove the absolute value bars, is that x plus 2 still a 2 when I plug in x equals 0? Well, yeah, so I'm not going to change that one. Okay, down here, I want to remove the absolute value bars, which I can, as long as it stays positive. Okay, what's a number less than negative 2? Negative 3. When I plug negative 3 into the absolute value of x plus 2, what do I get? I get the absolute value of negative 1, which is 1. When I take negative 3 and plug it into just x plus 2, do I still get 1? Well, no, I get negative 1, right? And so I'm going to multiply that absolute value piece by a negative in order to force it to be positive. Okay? And then for graphing purposes, let's go ahead, actually, you know what, I'm going to do this one underneath. Y equals, we have factor out a 3 on top, which will be handy because that will allow the x plus 2's to cancel. Down here, factoring a 3 out on top as well. We'll let my x plus 2's cancel. Okay, leaving me with, in the end, y equals, for the top one, 3 if x is greater than negative 2, and negative 3 if x is less than negative 2. Okay, graphing it. Y equals 3 is up here. Okay, what's the only piece of this y equals 3 that I'm keeping, though? Okay, greater than negative 2. So I'm going to erase everything that's not greater than negative 2. Keep the rest of it. Whole or point? Okay, well that would be a whole. And then our y equals -3. Okay, y equals -3 is down here. Okay, what are we keeping? Okay, well that would be less than -2. So erase everything that's not less than -2. And whole or point? Whole. Okay. And that's objective 5.